to the presentation of a review on the video summarization for glaucoma detection. My name is Correia. I am a master's student in Electrical and Electronic Engineer at Polytechnic de Leiria, and I will show you the motivations and the main reasons behind this study. This presentation will follow this script, initially presenting the glaucoma issue and how it affects the human eye, followed by the motivation for this study. Then, it will be presented tools that might help with the proposed idea, such as video summarization allied with glaucoma detection. After, some results from the state-of-the-art, showing how these methods are performing today. And by the end, some conclusions and final thoughts will be shared. So, what is glaucoma? Glaucoma is a serious disease that arises as a result of increased intraocular pressure. It is the second most common eye disease. It is hard to detect in early stages, can silently develop through the years. Sadly, it is incurable, but it can be slowed down with the correct treatment. The best way to prevent it is by doing regular visits to the ophthalmologist to perform a precise diagnosis with professional equipment. But how the vision loss happens? To explain that, it is important to know how the human eye works. When the light contacts the eye, the first layer to transpose is a transparent layer, the cornea. The cornea allows light rays go through the eye, changing its directions and making it converge inside through the lens and reach the retina, where the light will be absorbed and turned into electrical impulses and finally sent to the optic nerve. The retina has two parts that stand out, the macula and the fovea. The macula is the retina's central area and has more photosensible cells. The fovea is the macula's central point, where the light rays are focused. The glaucoma tends to damage the blood vessels close to these areas, due to the intraocular pressure compromising the eye health. In this picture, it is presented an example of several eye-affecting diseases, so you can have an idea how the eyesight is affected by them. On the top left, we have a healthy field vision. On the top right is how a person is affected by macular degeneration. On the bottom left is a diabetic retinopathy. And on the bottom right, we have glaucoma, which is the topic of this study. As mentioned before, the best way to prevent glaucoma is by doing regular visits to the ophthalmologist and perform a precise diagnosis with medical equipment. Here, it is an example of one type of equipment that is capable of capturing a high-resolution picture from the retina, with all the regions of interest exposed. It is quite simple, right? Scheduling these visits aren't a big deal, at least for some people. That's why it came to mind. For some individuals, this task can be difficult to accomplish due to several restrictions, such as low incoming resources, geographical adversities and traveling restrictions. Also, logistically, due to its dimensions, relocation to professional equipment can be expensive, thus becoming unavailable to bring them to remote areas. Usually, poor people are the most affected. Sometimes they don't even know why they're losing eyesight. To mitigate it, this study was proposed. As an alternative, some low-cost products are available in the market that copes with this need. These devices, which can be attached to a smartphone, enable capturing images for the retina. Of course, as a major drawback, lower quality imaging is acquired when compared to professional equipment. That's why some techniques may be handy when talking about video capture to perform a summarization. As a result, a more detailed image is expected as output, which can be used as a pre-screening approach for specialists in eye health. The specialist may recommend performing a more detailed diagnosis if the patient presents a suspicious glaucoma. Here, it is possible to see the output from a video capture with the help of one of those devices mentioned before. The quality sure is not optimal, but with some computational techniques, it is possible to extract the areas of interest. So, why video summarization? Well, video summarization is a technique that aims to extract important information from a video. Depending on the objective, it can summarize into a smaller video or just a single picture. It benefits from machine learning features, which means that you can always adjust your algorithm to match your desired features. Nowadays, many applications use video summarization as a method to extract important information for a large amount of data. In this example, we were able to train a model to recognize the retina from an input video. As a result, we got a boundary box where the retina was located in all frames. That is, if this model was trained well enough. For this study, it is interesting to be able to crop the maximum of frames that corresponds to our criteria. After that, the idea is to extract the interest area and summarize it with a deep learning method. And then we can finally input the summarized result in another filter, that is, a glaucoma detector, also based on deep learning method, which is our next topic. Here, we can see an example of a method that blends two images with corresponding points based on pixel distance between them. As a result, we have a more expanded and detailed image. With a video recording for our cell phone, this method can aid to maximize the retina exposure, making it easier for our glaucoma detector to resolve a result, which we're gonna bring this topic in the next point of this presentation. In the field of glaucoma detection and any other related eye disease, the usage of specific equipment for eye screening is mandatory. Several diagnosis methods can provide different retinal captures, such as optical coherence tomography, fundus autofluorescence, fluorescein angiography, indocyanine green, and colored fundus photography. Each one has its perks and advantages. In our case, the last one mentioned is the method that most correlates to a cell phone video capture. Here, in this example, we can see the difference between a healthy eye and a glaucoma-affected one by CFP capture method. In this case, the metrics for evaluation here is the optic cup and the optic disc size ratio. Usually, the cup size is about a third of the disc, and a glaucoma can cause an enlargement of this cup. This can make the cup to turn into an oval shape, stating that the diagnosis might be positive for glaucoma, indicating that further medical analysis may be needed. With all the methods trained and prepared, the idea is to follow this logic where we make a video capture with a cell phone and input it on a video summarization method to summarize the features we have selected for our glaucoma detector. The output should indicate the patient is suspicious or not. If they have any sign of glaucoma, a more precise diagnosis should be required. Now, with a defined plan, a review of the state of the art was needed for both video summarization and glaucoma detection. The review was based on the following questions. Which methods can perform video summarization? Which methods can help identify glaucoma in a summarized image? From those methods, which are realistic to be implemented specifically on low-quality acquired images. And it is possible to adapt those methods in multiple combinations with other methods. The research for both video summarization and glaucoma detection articles was performed with the following inclusion criteria. Studies that have performed at least one method for video summarization or glaucoma detection. Studies that applied deep learning techniques. Studies with a relevant medical background. Studies that present their respective results or scores and datasets. Studies that were published between 2018 and 2022. And of course, studies that were published in English. The reviewed studies with the selected inclusion criteria were searched in ScienceDirect and i3 Explorer databases. After following the questions and inclusion criteria, there were selected 44 articles. In the screening phase, 6 were excluded due to divergences from the medical background. In the eligibility and analysis phase, 20 out of 38 articles were excluded due to their relevancy and being redundant, leaving the final 18 articles included for this review that might contribute with our objectives. From the reviewed articles, these are the ones with the best results in the video summarization topic. The F-score is the metric to evaluate the method. Almost all the reviewed studies present both SunMe and TV-Sun datasets, as these datasets presents a conjunction of videos from daily life events to news reports. In this section, it's worth mentioning 2 works that stands out from the rest. One being the dual-path attentive network method for the high score on TV-Sun dataset, and the SUM GDA with the highest score in the SunMe dataset. In glaucoma detection, things changed a bit. The reason for this is that not all works use the same dataset, which means the quality of the acquired images can differ and produce a significant change in the accuracy. Some of them trained just with a smaller fraction of the images within the same dataset. This also may contribute to a different result. Although we can say that accuracy present in the results are pretty high. It is worth mentioning the RCGA with SVM as the highest score accuracy for glaucoma detection from the reviewed works. It is important to notice that within all the reviewed works, there was not a single one that used a CFP with low-quality imaging, which means that we might have to face some problems adapting the algorithm to our objective. But to ensure that this is really an issue, we must try to review the methods first and then evaluate the results. As stated before, despite the accuracy of the methods being high, it does not replace the professional diagnosis, which means our objective is to serve as a pre-screening method to mitigate glaucoma for those in most need. It is expected that after the conclusion in the upcoming tests, we might have a new algorithm capable of performing a summarization and detection of glaucoma from low-quality images captured by a single cell phone. I would like to thank your attention and hope to see you soon.